You have to understand. First off, what transformation creates similar figures? Dilation. Dilations create similar figures. So the angles are what? Nope. The angles are congruent. And there's one even more important thing about similar figures. The sides are what?
The same.
The corresponding sides, actually I should probably add that detail in there. And even here, the corresponding angles are congruent. The corresponding sides are...
Yeah.
Nope. Because if the angles and the sides were congruent, the figures would be what? Congruent. If the sides and the angles were congruent and they were the same shape, those would be congruent figures. I said they are similar.
Oh.
The angles are congruent and the corresponding sides are...
Different.
Yeah, they are different, but there's a specific way.
Proportional.
Thank you. Right? That was the whole thing. Remember how we talked about the scale factor is a what? Starts with an R. Ratio. Well, dilation is a transformation. But the scale factor is a ratio. What does it mean to be proportional? It means that the ratios are the same.
So they're not congruent or they're the same?
No, they're not congruent. Congruent means that the side lengths are the same. Proportional means that the ratio between the side lengths is the same. Right? You can actually go back and look at the previous problem and see it. Are these congruent?
No.
Very much no. Remember, congruent means that they completely, perfectly map under an isometry. The side lengths are the same, the angles are the same, but are these side lengths the same?
No.
No, very much no. But if I look at the ratio between the image and the pre-image, I get the same ratio every time. And I can use that ratio, that scale factor, to find unknown values. That's the whole point.
Which makes those two figures similar.
Say again?
Which makes those two figures similar, right?
If the sides are proportional, right? A dilation is what creates similar figures. But that means that the angles are congruent and that the sides are proportional. And y'all made me want to cry when I looked at 1.10.
I did good on it.
Y'all, if we talk about a dilation, which 1.7 and 1.8 were dilations, are the side lengths the same after a dilation?
No.
So are those features preserved?
No.
Side lengths are definitely not preserved. In fact, everything to do with size is not preserved. What features deal with size? Side lengths, perimeter, area.
Angle measures or no angle, something like that.
Nope.
No.
Angle is one of the few things that was preserved. Size, how big the figure is not preserved.
Orientation.
What do y'all think? Was orientation preserved?
No.
Look here, if I start at A, what comes next?
B.
B prime, C prime, D prime. A, B, C, D. Was orientation preserved?
Yes.
So you could have looked literally at problems on the task to figure this answer out.
Yeah.
So orientation was preserved. What else? Shape. And there was one other big one, and angle measures. These are the features that are and are not preserved. You need to know about all the features that are and are not preserved for each transformation. But you can also just draw a quick example of each to help remember what features are and are not preserved. Y'all ready to work on your review packet? What do you not understand? Say again, Kelsey? I mean, I can come and check on you. You don't understand this, or you don't understand something on the review packet? Okay, then I'll come and help you. But remember, you can always work on something else until I can get to your group. So we should be working on the review packet, practicing our transformations. Don't forget, practice looking at the operations. Say again? The test is supposed to be tomorrow. Remember I said if we aren't quite done, but you're actively working the whole day, then I might extend it one more day, but it is supposed to be tomorrow.